Let's experiment with the pointer a bit more. How about we choose a space in memory and drop a piece of data there? We can do this by pointing to the address of the space in memory we want to access, like we did with the counter variable. This time we do not have a variable, so we will have to type out the address. Remember, with a counter variable, we pull the address from the variable using the variable name with the ampersand or the and sign. So let's choose, how about we choose 0x20000014. 14 is right under 0x2000 in the memory view, so we wouldn't have to search again to find that address. So let's try this and see whether we can drop a random data in memory, and you would see the penetrating power of the point. We can do this by telling our pointer which address. Remember, our pointer is called pt. Pt equals okay, we said the address should be 0x to 12345614. Actually, it should be 5. So let's look at it again. It should be 8 digits, as we know. 1 2 3 4 5 6 7 8. So there's the 14. I chose this particular address because it's just the second row, so that we can see our variable and the data we drop in the same window without searching, as I already said. So let's choose this address. That's the thing, if we type out the address just like this, it wouldn't work, because right now it's just a number. It's not an address to the compiler, it's just a number. It might as well be someone's age. So what we have to do is tell the compiler, we have to add the parameters of an address to the compiler. First of all, addresses are unsigned integers, and we can indicate this by adding a capital U to the end, like this. Now we've told the compiler it's an unsigned integer. There's one more thing we have to do. We have to typecast it. We have to use something known as typecasting to tell the compiler this number over here is an integer accessible by a pointer, and the way we do that is open two curly braces, type int here, space, and then asterisk. So now we have pt pointing to this address 0x200014. So now, how about we put some data there? We can play with our hexadecimal alphabet. How about we drop some beef at this memory address? And we do this just like we did over there. You have the pointer, or we did not do this. You have the pointer, just assigned the value you want to place there. So first of all, pt is pointing to this address, and now pt should put this at that address up there, and the address and the value we're talking about is 0x0004 beef. So we put in beef at this address. Let's compile and see whether indeed the compiler would accept this. Okay, we have 0 errors. That's good news. So let's go to the debugger again, and okay. So back to our view. So we're here. Yeah, you see, this the address. This where we place in the beef is 200014. Because it's right under where our global variable is going to perform its changes. So let's do our iterations and see the changes. Okay. The global variable is next. So the next thing be our pointer pointing to our new address. It's pointed there. So the next one, if you check in the disassembly view, you realize the next operation to be performed will be to put our beef in register R0. If you check R0, R0 has our beef, and if you check the address 0x200014, the beef is placed there. So this is the power of pointers. It gives you this access to every place in memory. You can type the address and type the data you want to put there, and it does that very efficiently, and it reduces the amount of instructions needed to access or store data if we use the pointers directly.